Welcome back to another web development podcast episode where we help aspiring developers get jobs and junior developers grow. In this episode, we're going to be diving into the topic of essentially what is testing, why should you care about it? And so I brought on Ben, who has talked quite a bit about this topic. Ben, thank you so much for coming on.
Thanks for having me, Don. Great to be here.
For sure. I'm looking forward to this conversation. So I guess, who are you and why should people care what you have to say?
I am a self-taught software engineer from before boot camps were a thing. So in the fall of 2008, you may recall there was a big crash in the markets, and I quit my career in theater and TV production to just set out and be what I thought at the time was a web designer. And I didn't know that that was anything different from software development. I had just known that I liked fiddling around with code, and it was an incredibly naive decision that I was able to make because no one was depending on me. And it took me a while learning as I went to figure out that I was way more interested in software than I was in web design and find that as a career. And over the course of about 2 years, I got a job. I had a career. I found my way to being the associate director of web development for an agency in multiple cities, and then went and taught a boot camp because I was burned out and tired. And so where web development, learning to write code and sort of finding my way into that industry without credentials was like the most empowering thing I had done in my life up to that time, especially coming out of making freelance artist salary and into like actual tech money. Teaching other people to do that and enabling other people to follow that same journey was exponentially more, more empowering to me. So since then, I have been I was a bootcamp instructor for a while. I have had full-time employment most recently as a staff software engineer, but I am now a consultant and a trainer. And I've done a lot of thinking about why testing specifically, when considered in context and really considered carefully, is something that enables consistent growth as a software engineer. Like, you can come back to this topic kind of wherever you are in your career, and it helps you understand how to make better decisions in the structure of your applications, not just for the purposes of testing. There's a long-winded answer, I suppose, of why people should care, but that's about me. You'll see I'm a verbose kind of guy.
Sounds good. Looking forward to hearing more. Okay. So, and yeah, I think we met once at Full Stack, right?
Mm-hmm. I think so.
Yeah.
We used to pass in the hallways, I think, as you came in to teach the evening classes and I left teaching the daytime classes.
Yeah, just to clarify, I didn't teach there. I was hosting a meetup there.
Ah, got it.
But yeah, I do remember that. And a lot of people have, said a lot of good things about you. So that's why I decided to bring you on. But yeah, I can tell you right now, in terms of my knowledge with testing, even my priority of testing, it's all over the place. I'm open to different opinions. I've worked at companies that prioritize it more. I've worked at companies that do not prioritize it. And so testing is a really interesting topic, and people have different conceptions and even misconceptions of testing. So that's what we're going to be diving into today. But yeah, I'll let you take it away. What do we have to learn today?
Well, so what I found usually when I want to talk about this is it helps to know where people are when coming into it, because as you said, like there's a heap of preconceived notions about testing, and people come at it with different ideas about what it is and why you should do it. And so the first thing I usually do when I'm talking about this is to level set with the people that I'm talking to, so that you will be a proxy for the people that I'm talking to, or I'll just talk to you, and I'll turn the question right back around to you. Like, what do you think testing is? What do you think it's for? What role does it play in your development experience, in your toolbox? And we'll start there.
Sounds good. So when I build let's just say like when I build a personal project or when I build an app that I think I potentially want to market and just put a pricing model around, et cetera. Like that's usually why I code nowadays. I want to get features out. I want to get that feedback very quickly. And so I would tend to sacrifice my priority in testing quite a bit. The value I find in testing is testing complicated methods that's doing a lot. And maybe I should break that up into different methods, but like crucial pieces of my application where like, if this breaks, that's bad, right? And so I try to prioritize my features and the amount of tests I write for those features based on how important they are to the users. So I find testing gives me more confidence that I'm going to have less crucial parts of my code break. Like in a professional setting though, I find unit tests, integration tests, I find it's a little bit more helpful for, again, like as you scale, I think it's very easy to have some sort of regression, and you want to try to minimize that as much as I can, but it's essentially like trying to prevent that regression when you add new features. So I think as you scale, it can basically make the company a little bit more scalable in terms of getting features out faster without accruing tons of technical debt from the bugs that you're creating with the new features that you're implementing. So for me, it's kind of like a confidence thing in the crucial pieces, but it's also, I'm not going to dive into like the specific types of testings. I probably have different opinions about that, but it's also about not regressing the application. So, but with, let me give a little context with that. I don't prioritize this. I prioritize feature work because I focus on startup work, and the goal really is to get those features out and get that feedback quickly. But that's my mindset with testing. So what do you think?
I think that's all correct. I think this is the thing, is that testing is a tool. It is not a dogma. There are plenty of people who will bring their dogma around testing and say, you must. And the thing is, like everything in our industry, it's a tool. There are places where it's incredibly valuable. There are places where the effort that you put into it is not worth that amount of effort. Every line of code that you write is a liability. So you need to recognize that the effort you put into tests, the lines of code that you put into your code base, even if they are tests, still become a liability. So I would ask the question, like, where do you think of your tests as more proactive or more reactive in nature? Are you testing something that you have built to make sure that it doesn't change, or are you writing tests to define the behavior that you conceive of your application following, and then writing your application to that behavior?
Gotcha. So more of like a test-driven behavior versus writing tests after you build the features. I'm going to I'm going to qualify this by saying, like, the term test-driven development is so overloaded. It is a very specific dogma that people will follow. But yes, think of the lowercase TDD, like you are writing your tests first versus writing your tests after. Are you specifying, or are you qualifying? Gotcha. So I write them after.
Okay.
I do think they can be a tool to spell out exactly what your code is doing, but in practice, I have not found that to be helpful.
Interesting. And so what makes you go back and say, boy, I should write a test for this?
It ends up being a very crucial part of the application where if this breaks, it's going to really impact the user. Or the method it might be even a little bit more bloated, and I'm very worried about, like, even just parsing tons of text. I've screwed that up before. I want to have a little bit of confidence that this method isn't going to screw it up again.
Yeah, interesting. So I think I follow most of those same considerations as I'm deciding what to test. But the thing that I try to follow, so if you want to get a bit formulaic about it, right? Like every test I think of a test as a specification. I will not lie and say that I write every single test that I've ever written. I write it before I write the production code that fulfills it. But I try to, the act of learning to write your tests first allows you to start thinking about the behavior of your code before you start writing the code. It gets you into the habit of thinking, what should this really do? And so I think of a test, the term test and spec are used pretty well interchangeably, but they're actually quite different in their, in sort of what they imply, which is like, if I write a test, I'm testing that something continues to do a thing that I already made, right? I wrote this thing and it does what I want because I verified it, because I looked at it and it did the thing. And now I want to make sure that doesn't change. So I write a test. If I write a spec, I am saying this thing that I'm about to write should fulfill all these specifications. And you can argue all day long about whether you should write tests first or last. I actually don't care if you write your tests first or write your tests last. What I do think that you should do is get in the habit of thinking in specifications, even if it's just a checklist of when this chunk of code should behave, it should fill this role in my application by conforming to this contract, by doing these things, right? If A, then B. Every test, a well-structured test is set up in 3 steps: given, when, and then. So given a set of preconditions, when I perform this action, then I should see these results. And that terminology is borrowed from BDD, behavior-driven development, which is a subset or a variant of TDD that we won't go into. It's more about giving a common language to everyone in your organization rather than just engineers. But it's more commonly referred to when you're speaking in just a software engineering context as arrange, act, assert. So you arrange all your pieces, you pull everything you need to execute your test, then you act on that test, you do the thing that you want to make sure does the thing right, and then you examine the results. You assert that the result of that operation is this, 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 and this, or through an error or whatever, validated with this message, whatever it is. And by thinking systematically in that way, you can start to pick out the pieces of your application that conform to very focused, very specific behaviors. And I'm sure we'll come back to that, because the term behavior becomes a loaded term, that you want to test for behavior, not for implementation. You may have heard that before, but the idea that the first thing that I will tell anyone who wants to start writing tests is start thinking in terms of arrange, act, assert. What is the discrete piece of behavior that I'm trying to test? What do I need before I do it? And what do I assert after doing that piece of behavior?
That makes sense. Keep going. I'm just listening right now.
Yeah. So usually what that does is, when you start thinking about this, and like I said, learning like using test-driven development, or I say test-first development, so it's not the loaded TDD term, but like writing your tests first gets you in the habit of thinking this way, and gets you to start realizing before you've written code, to start understanding what is going to be hard to test. If I try and write this code, what is going to be hard to test about it? If I write the tests first, I start thinking like, oh, if I just write some data structures in memory and run a test against that and examine the result, can I then write some piece of behavior that performs all of that logic, performs all of the important logic that I need to perform without ever touching a database, without ever touching an API endpoint, that is just focusing my behavior and drawing a boundary around, here is the operation that I need to do. And then you realize that there are other responsibilities, the responsibility for getting things out of the database or putting it back or handling API requests, handling HTTP calls, whatever. those are separate responsibilities. Those can be separately tested. And so you start figuring out how to arrange the boundaries of your application in a way that you can write tests quickly. You can make them easier to maintain. They run faster if you can move most of your logic into things that don't require touching a database or touching an external API, or running calls against a live API that you have to spin up. So that's a big part of it. And from there, you start to, when you kind of start getting your feet under you there, you then start to learn how to carve what are the external facing behaviors. So if you think about your test as a black box, the system under test, specifically the piece that you are in the act step of your arrange, act, assert. If you think of that as a black box where you're giving it inputs and you're receiving outputs and you cannot see anything that goes on inside of it, you start writing your tests from that perspective, from how do I interact with this object without knowing about its internals. And then once you start getting into that habit, that allows you the ability to refactor, because code is a living thing. Your code, the code that you write, is actually a blueprint for a machine that is going to be built hundreds of times this year, thousands of times this year, right? You're writing blueprints. You're not building anything. You're in your editor. You're writing blueprints for a computer to build an application. You're going to change those blueprints around all the time. And so what you get in the habit of doing and what you learn to do with testing is figuring out where those boundaries of behavior are. These are the things that must stay constant. And behind those walls, inside that box that my tests can't see, I'm free to optimize for performance or readability, or I have to upgrade a library that I'm using under the hood. I change the API within it. Like all of those things, you're free to do that as long as you're not changing the outward facing behavior. Does that make sense?
Yeah. I feel like the way I've approached testing, like you're kind of implying that the way you're encouraging to approach testing, it's more about like developing a mindset to develop your code based on specs. And when you do start writing tests out initially, you're going to start separating a lot of the concerns of what things are doing. And so that's going to influence essentially how you structure things, how you separate your concerns in the actual structure of your app. So it just sounds like what you're essentially pushing for with testing is very influential in how you separate your app.
I think that's a big part of it. I think the other side of it is that testing is a skill. So people say, we don't have time to write tests. Teams that say we don't have time to write tests usually are teams that have never written very many tests. And so it is a drain on their productivity because it's a skill that they're still developing. If it's a skill that you've developed, and I'm not saying we're striving for 100% test coverage or again, dogma. I'm not preaching dogma here about how much testing to do, but if it's a skill that you have, there are plenty of times in your development that it significantly speeds things up. Because the feedback cycle of how many times, think about, I'm sitting here trying to get the implementation right of some function, right? If I already know what that function needs to do, if I'm not still like sketching out what the API of an object is, or like sometimes, if you're still working out and moving things around, that's not the time to start writing tests. But once you have a good idea of the shape that your objects are going to take or your functions are going to take, what their API is, your inputs, your outputs. If you've developed the skill of being able to set up a test harness, that's a one-time thing in your application. and be able to quickly write out some tests that say, with these inputs, run this function, expect these outputs. Think about how many times you go, if you don't have a test written for it, you're going to go and you're going to run some little script. You're going to try and isolate, how are you going to isolate that thing that you're trying to debug? Or are you trying to do it indirectly by observing the system on the whole and seeing dropping a whole bunch of console.log statements through the whole of your application, like all of that debugging. If what you know is somewhere in this function, I'm still working on how this fully implements it, like a text parser or something along those lines. Like, write that test and start implementing. And it's giving you feedback literally every time you save that file. You see, is it working? Nope. Is it working? Nope. Is it working? Nope. Is it working? Nope. Yes, these 3 cases work. These 2 broke. Oh, I fixed this one. Now this one's broke. Like, all of that, you don't have to go through and manually check all those things. So like there are places where this, having invested in literally just the skill of what would a test for this look like? Can I sit down and quickly write this out? These 6 inputs give me these 3 outputs, whatever. It will drastically speed up the implementation of a particularly complex thing. Again, not every single thing that you're going to write. Like, that's, I think, you get a lot of the sort of binary arguments of like, write all your tests first, never write tests, or write all your tests last. It's like, well, no, there are times when it's incredibly valuable and it will speed you up. And there are times when you're still working out how things should look, and writing a test ahead of time is premature, right? I feel like I went off on a tangent there.
No,
Did I lose the thread?
No, I think that's really helpful. I think you're giving a lot of good context that's relatable. You had mentioned this idea that, like, and you probably experienced this, some companies, some software engineers, some teams, like, really prioritize a percentage, a test coverage percentage, right? So there are probably tests that are not that valuable, that will slow down feature work. What would be like an example of a test or something you would test that probably doesn't need to be written?
A test that doesn't need to be written is, I could give you a few classes. Generally, a test that is testing trivial behavior doesn't need to be written. And now, obviously, that is a little bit vague. So let's think. Say, well, this isn't quite the same as trivial behavior, but if you have a library, say you're using an ORM in your application, and it is, off the shelf, mature product that millions of people use every day, there's no reason for you to write a test that is only testing the functionality of that ORM. I guarantee you that ORM has tests for what you are doing, and it works fine. As long as you are using their API as it is intended to be used, like the tests already exist. There's no reason to write a test for that. Now, the flip side of that is, as you start to compose those behaviors, like I'm going to create an object that has these validations and save, when I save it, it should throw these errors. This needs to be less than that. Those sorts of things, that now you are creating an external contract of your object, right? You are defining behavior of that object that is not going to be tested in the library itself. So that's where you're going to start writing like, oh, this test, when I validate, say I want to validate this object, it should throw these errors, or it should ensure that this is less than that, or whatever. A case of like trivial behavior would be, gosh, why am I having trouble pulling something up here? I don't know. You've got a function that just concatenates 3 strings together, right? Like a function that gives full name with, first name and last name. It's probably fine, right? Like if you're prioritizing speed, if you're under a lot of pressure to deliver, you're probably fine. You don't need to write that test.
So what you're saying makes complete sense. And I'm glad you're saying it because it validates that I've been doing things okay so far. Yeah. So, when I work on teams, and I'm glad you mentioned like, okay, this function concatenates a name. Is this really worth testing? It's simple in complexity, but it's also simple. I mean, the impact might be a bit more depending on like what's being displayed, but like the complexity is simple, and that's what I read into that. But I remember I'm just thinking of someone that I worked with, second company, very good developer. I've even had him on the podcast before, but I don't know where he stands at the moment, but like he did not prioritize tests at all. He thought unit tests were worthless. And the thing is, his code, it wasn't like there weren't a lot of bugs that were produced from his code. And he had this mindset in the way that he structured code, and like he'd focus on things like separating the concerns and where it would conventionally make sense. It'd be consistent with like how the entire team would do it. He wrote pretty good code. It's not like it was void of bugs, but he had a strong preference. Unit tests are usually a waste of time. You had originally mentioned like teams that do this, teams or developers that have this mindset, they usually just lack the experience of writing tests. So it's a skill that they have to build up. And we were in a startup at the time, so we had to get these features out quickly.
Sure.
And so you had mentioned that, teams like this, they really just don't have the experience of writing tests, and that's why it's slowing down their feature work. I know you don't really have a lot of context for this individual, but if you were to have a conversation with this individual, and you just basically, like, you saw his code, most of it worked, it's pretty well written, and it produced a few bugs, but like the mindset is like unit tests are completely worthless and they slow me down. Like, what is your response to that? What's your advice to him?
Well, the first thing I would ask this individual is I won't presume he or she. He. I thought you said he, but the first thing I would ask him is what he means by unit test, because that is a term with very, very fuzzy definitions, and everyone has a different take on it. The best one I've heard is a unit test defines a unit of behavior. So if the sort of classic place where a lot of people bring unit test, and I realize I'm getting away from your specific question, and so we'll get back to it. But the idea of a unit test is like the test of a single method on an object. That's a unit test, but that falls apart in the case of like a getter and a setter. Like if I have a method that sets a value within the object and another method that gets that value back out. In order to know anything useful, you have to test both of those methods. You have to test that when I call get, I can access that value, that internal value by calling, when I call set, I can access that internal value by calling get. So like right there, the idea of a unit test, like you can see different people have different notions of it. And I would say that this person likely when they say unit tests are worthless, I would say first off that they're probably thinking of too fine-grained of behavior to be testing, to go in and write, if you're testing every single method, particularly in a startup environment, like that may actually slow you down to the point, like testing. Here's the thing. Testing does slow you down. You cannot write as much code, as much production code in as short a period of time if half of it is tests. But if your metric for what you're delivering is lines of code or even features pushed out the door, I would say that's a flawed metric to start with, because what's going to slow the next engineer down whose work interacts with the code that you wrote? And that is going to be not having any idea exactly what your code needs to be doing or if they've broken it. so they might have to spend a bunch of extra time trying to validate it. Then they're going to miss something. And the next engineer after that is going to have to deal with whatever bug came out that gets reported 3 weeks later. And then you have to go and figure out what introduced this bug. Why did that introduce this bug? So you have to learn about engineer number 2's work. And then you have to go back and you have to learn about engineer number 1's work and how those two interacted and why the bug was introduced. And this is all happening 3 weeks after the fact, right? So I think it was Martin Fowler I saw he spoke at some conference that they hired him for like 10 minutes to speak for 10 minutes. And he even started the conference was like, why did you pay to bring me out here to just speak for 10 minutes? Like, I could have talked for way longer, but you want me to tell you something useful in 10 minutes. Fine. So he burned 2 minutes of his 10 saying that and then said, basically the flawed argument of why we test that so many engineers bring is we test for our craft, to be good at our craft, to do it right. And the truth is that argument always fails in the face of profit, in the face of, are we delivering value to the business? And what you have to recognize is that writing tests is not an investment in the code I'm writing now. It's an investment in the code that is going to interact with this code. It is an investment in the time that your colleagues are going to spend trying to make sense of what you've written, because code is so much easier to write than it is to read. Like you always, even like, how many times have you gone back 2 months after you wrote something and you're like, what? Mm-hmm. And you knew exactly what you were doing with all the context in your head that moment, right? And the thing is, it's not actually important that you grasp the intricacies of every line of that code. What's important is that the external behavior, the behavior that is outward facing, that whatever other code in your code base interacts with this piece of code, that behavior doesn't change unless it's changed intentionally. And so this is what I mean by thinking in terms of testing allows you to start figuring out what are those pieces of behavior in your application, of consistent behavior that you and your team can build a vocabulary around, and can say like, this API around this section of our code does not change, or when it changes, it will be documented in these tests, or we will know if it changes accidentally, and we are free to change whatever we want inside of it as long as these pieces don't change. And that's where you get superpowers, right? That's where you are now able to work with confidence. The people interacting with the code that you've written can work with confidence, knowing that they haven't broken it. New engineers coming onto your team can go read through tests and understand what things do. But again, if you're testing every single method that, works internally, especially in a startup environment where that's going to change weekly. I'm actually working with a client right now in a very similar situation where like their business is pivoting like monthly. And so they're changing things left and right, but they are now in a quagmire of, we've written a ton of stuff, written it really fast, and we have to change it all the time. And we don't really remember how it works or what it's supposed to do or how it should behave. And so that's where I think that testing, again, with some intentional development of testing as a skill, of being able to write them quickly, and also being able to decide with your team, where are the contracts within your application that should not change, that are most stable, write the tests against those. And I think that, and recognizing that writing those tests is going to slow you down in the short term. You are not going to write as many lines of production code if you are writing tests while you do it, and understanding that that's okay. That if you track numbers of features shipped over time and regressions that come back, and you start writing tests and start investing in like intentional testing methodology, you will see an increase in velocity. You will see a decrease in defects. Now, again, depending on your business model, depending on the startup you're in, they may not care, right? They may just want to keep pushing things. But eventually you're going to hit that moment where, the hockey stick growth, and now you have to hire 20 engineers. Do you know what happens when 20 engineers start writing code in a code base that has no tests? I do. I've been in that code base. It's not fun. So if you don't have even like the framework of a bit of testing in there, no one's going to start it. No one's going to like put that foundation in, and it's going to be difficult. So that's what I would probably say to this individual.
I think that's really good advice. I do think software engineers can get a little bit of siloed into their own work, and their focus on growth is towards them becoming a better software engineer specifically, right? Maybe there was a little pride in what he said, and that's what it was. But our QA team at that company was also larger than at a company where we wrote a lot of tests. Yeah. And so they were looking for a lot of regressions. I can't say for certain if there were more regressions, but we had a bigger QA team, and maybe that says something. So I think there's a good argument to be made that, or especially like software engineers that do want to try to introduce tests, like I think approaching it towards like reducing regressions down the road, and even like the argument with the startup. So like I give the startup idea of like software engineers, we need to move quickly, we need to build features, that's what's prioritized, and eventually you're right, like down the road there's going to be more regression and there's going to be more regret towards that. But even with startup culture, like if you're pivoting a lot, like it just serves the business to expect, like maybe complete pivots. You're probably not going to be writing a lot of tests. You just want to get code out and test ideas. Right. But like, little pivots, new features, tons of new feature work, especially if it's going to be affecting any sort of like core components of your code, like that is going to, I feel like that's going to reduce the technical deficit down the road, and it's going to save the company money from hiring more software engineers to fix more bugs, or hiring more QA to be able to handle more regressions that come down the road. I feel like sometimes, startups kind of just have a window. We need to get this stuff done, and they're not thinking super long term, because long term, what you're suggesting, it does save companies money down the like, and it really does, but it's hard to convince, and it's not even convincing software engineers at a startup necessarily. It's convincing like the CTO who's listening to the startup owner, like we just got to get this stuff out. This is taking too long. Like I feel like there's a lot of conversation that I'm sure the CTO and lead engineers need to deal with. But what you're saying is like, this is going to save you money down the road.
Yeah, I think that's a really good distinction that you bring up, which is if it's not coming from the top of the engineering organization, it's going to be a very difficult sell. However, a lot of people say, well, management, our managers, our project managers won't let us write tests. I'm like, it's not your project manager's concern. Don't tell your project managers that you're writing tests, right? You do your job and they'll do theirs, right? But if you are, if you don't have buy-in from engineering leadership, that's a hard sell. Because it's not just I write tests, my code is better. It's I need to discuss with my team what needs to be tested, what contracts need to remain stable, what needs to not be tested, what makes a good test. Like those are value judgments, those are value calls there are no absolutes. You have to figure those out for your team. What optimizes your velocity as a team? I can guarantee you though that some amount of testing for pretty much every team is going to be better than no testing. I'm trying to remember where I read it in a book recently. I'm trying to remember which book. I think it's a Code That Fits in Your Head, where the the comparison, the author makes the comparison, Mark Seaman is the author, makes the comparison that accountants use double entry accounting as a failsafe on their work, right? And if you were not to use, like, any accountant who didn't use double entry accounting, now I don't know anything about accounting, so I'm sort of speaking third hand here, but would be found like criminally negligent in their job, right? Why are we not using the same method, right? We write some instructions to be carried out by little armies of unthinking robots, and we don't have any way of making sure that those instructions are correct before we feed them to the robots, right? Like, that's what tests are there for. They're there to make sure that you did it right. And they're there to make sure that the thing that you changed later didn't break the thing that you weren't looking at over here, right?
Yeah, I think that's a good way of looking at it. And I think you summarized kind of what I was also leading to, which I didn't solidify that in my mind. It's like, I think it really helps to have buy-in from leadership. It's hard to make an argument. Like, you can, as a software engineer, like, that's also going to be part of your job. It's like, if you feel like things are done or could be done in a better way, just articulate a good argument for it. Mm-hmm. I think that's a skill of a good software engineer as well.
I would say there's two parts to that, which is articulate the argument so that you get the whatever funding, time, leeway to try it, and then make sure that you have evidence that you can show. Like, make sure that you're running an experiment, right? Don't just say, well, look, we wrote tests, it's better. Like, show that if we write tests consistently, our regressions go down a month from now, or whatever it is. Figure out what that is, that you can then justify that you were right, and then get continued investment in turning the ship. Because otherwise, how many times have you been part of a team where, like, everyone says, yeah, we should do this thing, and somebody does a half-assed piece of it, and then it sits like this, like, vestigial organ in the code base over here where somebody tried to do a thing, or somebody tried to document something over here, and like, oh yeah, remember when Jane got some time to do that thing, and that looked like it was really awesome, but then we all got busy and it never did. And like, so like, if you get the, you need to be able to show that it was worthwhile in order to get continued investment in this. If it's a thing that you are actually trying to change culture or change procedure of how your team works.
I think that's really good advice. I like that. Okay. I feel like you did a really good job of kind of, instilling, just a way, like, the benefits of testing specifically. I feel like, even just the idea, it's not even just like, okay, we're going to be dogmatic, like, we need to do this test-driven development and write tests initially because it's going to write out the specs. But you're saying, okay, no, just have your specs. Like, that's also beneficial. Mm-hmm. And before you even start writing code. So it's, you did a really good job of spelling out essentially the mindset that you're trying to instill in developers. Even, like, you're using testing as an example, but, like, you also, like, how it's going to force developers to essentially separate concerns and prioritize things that should absolutely not change. And, things that, like, are actually where even we can put trust in, like, certain frameworks. Like, if you have an ORM, like, you should be able to trust that there are tons of tests, and it has been tested severely, but, like, these parts of our code, we probably should be a little bit more concerned with, and I can end up with tons of regressions down the road. Like, what I'm trying to say is you gave a lot of context towards developing a mindset of why testing makes sense and why software engineers should consider it. I thought it was, honestly, like, I have to rewatch this episode anyways. And then I go back and edit it. So I think this was very helpful. We're just about almost out of time. Is there anything that you want to share about testing specifically that we haven't covered before we end it?
I would say, just learn to do it. Learn to do it. It makes you a better engineer. And whether or not you bring it into the code base, it helps you to think about how your code should go together in modular ways. So that's all I would say.
Okay. No, seriously, this is great advice. Ben, I really appreciate you coming on. I've never really talked to you thoroughly about this, so I didn't really know what your mindset was, but I think this is going to be helpful. But before we do end, if you want to reach out to Ben, you want to learn more of what he has to say, and we're going to go ahead and link his LinkedIn and whatever else he wants linked in the show notes. But yeah, Ben, what do you want to shout out for us?
I would say I have put out a bit of content specifically for bootcamp grads, some free video lectures and things you can find on my website, benwilhelm.com. I've also put out a recent paid course for testing called Test Like a Tech Lead. You can get to that also through my website. That is geared towards bootcamp grads in their first job, first 1 to 2 years of their first job, where I cover a lot of this stuff. And yeah, LinkedIn is probably the place to find me on social. I'm the Ben Wilhelm that looks like this. And if you're listening to this not on video, I'm dashingly handsome.
I can attest to that. All right. Yeah. Hope you enjoyed the episode. Definitely feel free to reach out to Ben. Pretty friendly guy. You have any questions, you want to learn more about what he has to say about testing, follow him on his socials. But seriously, Ben, thanks so much for coming on.
Thanks so much for having me, Don. It's been a pleasure.